Hi friends, in the continuation of data science interview question answer series, we are moving to question difference between k nearest neighbor and k means learning paradigm. K nearest neighbor supervised learning, its used for classification or regression. K means is unsupervised learning and it's used for clustering. Primary goal to predict the class value of new data points based on its neighbor. In K-means, to group similar data points into K distinct clusters, partitions, model nature, K nearest neighbor, instance based or lazy learning, no explicit training phase. K means centroid based or eager learning involve an iterative optimization process. Training phase, KNN, the only training is storing all the training data points. K means involves iterative recalculation of centroid and reassignment of points until convergence. Prediction inference, KNN required calculating the distance to all training point to find the k closest one. K means does not predict a label, instead its output the cluster assignment for each data point. Output KNN, a class level majority vote or continuous value average weighted average. K means a cluster ID integer 1 to k and the final cluster centroid parameter k. In k nearest neighbor, k is number of neighbors to consider. K means k is the number of cluster to form. Boundaries, k nearest neighbor, the decision boundaries is non-linear and local piecewise linear. K means the decision boundaries in the linear a Bernoulli diagram based on centroids. COVID question, difference between support vector machine and logistic regression. Model type, SVM is discriminative, finding the optimal separating hyperplanes. In logistic regression, discriminative, a linear model used for classification. Output, SVM outputs a class level or distance to the hyperplane. Logistic regression output a probability of belonging to positive class P y equal to 1. Objective functions, SVM maximize the margin between the separating hyperplane and support vector regularized loss. Logistic regression minimize the log loss cross entropy between predicted and actual probabilities. Core idea, SVM based on support vectors data points closest to the hyperplane. Logistic regression based on sigmoid logistic function to map a linear score to probabilities. Hyperplane, SVMs focus on the data points near the boundary support vector. In logistic regression, focus on all data points to find the line that best separates the data. Nonlinearity. SVM easily handle nonlinearity via the kernel trick RBF polynomial kernels. Logistic regression inherently a linear model. Nonlinearity can only be added by creating polynomial features. Sensitivity to outlier. SVM generally sensitive to outlier as they often become support vectors and affect the margin. Logistic regression generally less sensitive to outlier than SVM, especially with L2 regularization data size. SVM works well with a smaller to medium size data set, especially high dimension one. Logistic regression works well with large scale data set due to its computationally efficiency. Google question, difference between descriptive analytics and predictive analytics. Primary question, what happened? Summarize past events. In predictive analysis, what will happen? Forecast future outcomes. Focus. Descriptive analytics historical data and its characteristic, predictive analytics, future trend and probabilities, output, discriminative analytics, reports, dashboards, summarize of past data, average sales last quarter, predictive analytics, forecast, scores, probabilities, example likelihood of the customer churning next month. Techniques, descriptive analytics, statistical method like mean, median, standard deviation, clustering, visualization. In predictive analytics, machine learning algorithm, regression models, time series forecasting, complexity. Descriptive analytics, simple to implement, typically standard business intelligence BI tool, moderate to high complexity in predictive analytics require model training, validation, and maintenance. Data requirement, clean stat- historical data for summarization in descriptive analytics. In predictive analytics, keen historical data feature and target variable for model training. Time horizon, descriptive analytics, past and present. Predictive analytics, future. Business value. Descriptive analytics provide insight into the business performance and status quo. In predictive analytics, provides forecast to make proactive decision and mitigate the risk. Please like, subscribe, and share the channel. Thank you.